Okay, welcome to Unit 5 test review. I hope you're all ready for the test while I change it from pale yellow to something that will actually show up. There we go. All right, part 2 test first. Remember, submitting it to the Dropbox triggers access to everything else. So if you're given an inequality, something like this, be able to graph it and explain your graph. First of all, we need to put it in a form that we can do something with, so let's transform it into slope-intercept form. We'll subtract 3x from both sides. Now we need to divide by 2. And we get y is less than negative 3/2 x plus 2. All right, we have a y-intercept of 2, a slope of negative 3/2, so 1, 2, 3, up 3 over 2. We're going to have a line something like this. We know we need to have it dotted because it is not equal to that line. Everything up to but not including. Y is less than that line, so I'm going to shade this area down here, and I can do a test point just to make sure that I'm correct. I'm going to use the point 0, 0 because I like it. It's easy. 0 times negative 3/2 gives me 0. Is 0 less than 2? It is. It's a true statement. 2 is a correct answer, and I shaded the correct area. Make sure to include your graph because graphing it is several points for the total. All right, part 1. You're going to be given a graph, and you need to be able to state the equation of the line in point-slope form. Notice that it's not going to cross the x-axis at a nice even place. You'll be given a couple of points, and that's all. So, first of all, we need to find out the slope. The slope is m equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2. This is negative 2 comma negative 4, and this is 3 comma 5. So let's plug in what we know. Minus 4 minus 5 all over negative 2 minus 3. That gives us negative 9 over negative 5, or 9/5. We have a slope of 9/5. Now we can select whatever point we want. Y minus 5 is equal to 9/5 over x, multiplied by x minus 3. Now notice if I had selected this point here, it would have been y plus 4 because we are subtracting a negative coordinate. Two negatives together make a positive. There you go, in point-slope form. If given the points 3, 2 and 5, 9, what is the equation of the line in standard form? First of all, we're going to need a slope. Let's make this our 1's and this is our 2's. So we have 2 minus 9 on the top, calculating slope, and 3 minus 5 on the bottom. That gives us a negative 7 over a negative 2, or a slope of 7/2. Okay. Now we need to find the equation of a line. Let's do point slope form. So y minus the y coordinate times our slope times x minus our x coordinate. Okay, from this point we can transform into standard form. We might have to go through a couple of processes, but we'll get there eventually. So y minus 2 is equal to, and by the way, this is the hardest one you will see on the test. Okay, negative 3 times 7/2 gives us 21/2. We'll add 2 to both sides. Oops, this should be equal, sorry. Minus 21 plus, and instead of writing 2, I'm going to write 4/2. 4/2 is the same thing as 2. It just makes the addition of those fractions easier. So we get 7/2 x Minus 21 halves plus 4 halves gives us negative 17 halves. Now, you might be tempted to stop, but look, they're asking for it in standard form. This, unfortunately, is not standard form. So I need to get some more room so that I can transform this to standard form. Okay, back to a pen. Hey, it didn't default to pale yellow. I guess I can't complain. There we go. All right, so first thing we want to do is get the x and the y together on the same side. So we'll get negative 7/2 x plus y is equal to negative 17/2. I did that by subtracting 7/2 x from both sides. Okay. Remember, standard form, you can't have fractions and you can't have negative numbers on the leading term. So let's multiply this by the inverse here. Notice how this makes all these cancel, yay, 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 and we're left with x. But that means we have to multiply this by 2/7/2, which gives us a negative 2/7 y is equal to, and we have to multiply this by negative 2/7. Now you can see why this is the most complicated one on your test. The 2's cancel, the negatives cancel, and we're left with 17/7. All right, we no longer have a negative term for our leading term. We no longer have a fraction on the first term, but now we created a fraction on the second term. We have to get rid of it. How can we get rid of it? We can multiply it by the opposite. If we multiply everything by 7/2, what do we get? Oh, I'm not by 7/2, sorry, by 7. My brain caught up with my mouth. If we multiply this by 7, what do we get? Negative 2y. If we multiply this by 7, what do we get? 17. Bingo. We now have it in standard form. X and y together on the left side, no negative term for our leading term, and no fractions. And again, this is the most difficult one you will see with multiple steps. So if you want to practice some of these, there are some practice problems in your textbook. I highly recommend it. All right. If you have some lines like this, what would be the equations? Y, in this case, will always equal 5. Can't equal anything else. And the slope of this line is 0 because our little skier dude is not going anywhere. His poles are down. He's sad. Okay, this one right here, x is always equal to 4. It's never equal to anything else. And the slope for this is undefined. What would be true about the equation? You have a couple questions on the test where they'll give you something like this and then have several statements for you to choose from. First of all, I'm going to transform this to something that I can tell. And I might do a quick little graph so I can see what I'm looking at. They might have something like one of the options may be that it has an undefined slope. One of the options may be that it has no y-intercept. One of the options may be that it has, that is a vertical line. One of the options may be that it is a horizontal line. For this situation, you would choose horizontal line. Just be able to recognize some true statements about an equation, and it is very helpful to graph it first if you want to have some scratch paper next to the test and just sketch one out really quick like I did. All right, what is the equation of a line whose slope is 3 and contains the point 2, 5 in slope-intercept form? All right, so they want slope-intercept form, but we're giving a slope and a point. So this shouldn't surprise you that first we'll want to make this in point-slope form and then transform. X minus 2. Notice I plugged in my value for my coordinate and then I plugged in my slope. All right, now we can transform this. distribute the 3, we get 3x, and 3 minus 6. We'll add 5 to both sides, and we get bingo. All right, next up in terms of difficulty is probably something like this. A story problem. The price for different size orders of donuts are given. Is this a linear relationship? Right now, we don't know. So let's just do a quick little graph right here. If we buy one donut, we'll pay 69 cents. 1, 2, 3, 4. Let's just go for 4. So 69 cents. If we buy 3 donuts, we'll pay 1, 2, 3, $2.07. If we buy 6 donuts, we'll pay $4. That looks pretty linear to me. I'm thinking it's linear, so I want to go ahead then and see if I can calculate a slope and a y-intercept. Now you'll notice the x-axis is the number of donuts, and the y-axis is the price. For ever how many donuts I buy, I'm going to pay this much. We have an x-coordinate and a y-coordinate, and we can calculate slope. Let's just take these two right here. I'll make that my sub 1 and this one my sub 2. So y's on top, 2.07 minus 0.69 over 2, that's 3. I was looking at the 2 I had written there. Okay, all right, there we go. When we subtract this out, we get 1.38 over 2, or 0.69 over 1. We have a slope of 0.69. We calculated the slope. What is the y-intercept? Haha, this should be something that you could intuitively do. You can calculate it out, but if you buy 0 donuts, how much should you pay? Yeah, 0. So how much would 5 donuts cost? Well, if one donut costs 69 cents and it's a linear relationship, you can graph it out, or you can go 5 times 0.69, which is equal to $3.45. Hoping we can get done in time. Which of the following are solutions to the inequality test? When you see this, you essentially have 2 options. You can plug and chug, or you can draw a rough graph and graph it and then put the points in and see if they are within the domain of this. If we were to solve this, we would first subtract x from both sides. 3y is greater than or less than negative 2x plus 9. Divide by negative 3. Now remember, if you divide by a negative number, you have to swap out, switch the orientation, flip the operator, however you want to think about it. All right, we have a y-intercept of negative 2 and a slope. Oops. I almost did that wrong because it's a positive 2/3. There we go. Ignore that. Okay, I did a solid line because it is less than or equal to. Y is less than. Where is y less than? On this side of the graph. So let's just do a quick check. Negative 1 and 5 is going to be up here. That's not a solution. Negative 3, negative 1 is going to be right there. That's not a solution. 4 and 2 is going to be right there. That's not a solution. 3, negative 4. You can check that by plugging it in and seeing if it makes a true statement, but I figured you could probably manage that. So, be able to graph an inequality like this, and we've kind of done this already. First of all, subtract 3x from both sides, and we get negative 3x minus 4. Find your y-intercept, calculate your slope. It's going to be a dotted line because it is not equal to. Y is greater than. Do a test point of 0, 0 to see if we are true. Is 0 greater than negative 4? Yes, it is. This point is a true solution. We know we did it correctly. Phew, that was a mile a minute to get through all of that. Please use the pause button if you need to. Stop by Live Help if you have any questions, and here is something to usually smile to get you on your way. All I can say is I would prefer to have the maple one back here that still has the frosting intact. Good luck, and send me any KML questions if you get stuck.